Hi, everybody. All right, we are going to be looking at X probability and the sections of new, number 4, 5, and 6. So counting principle, permutations, permutation, and combination notation. All right, so let's look at the first one, the new section. Okay. So this new section right here is going to be probability of dependent and independent events. So this one we're looking at pick a card at random without putting back the first card. You pick a second card at random. I was probably picking a 4 and then picking a divisor of 12. All right, so the first one is going to be a 1 in 4 chance. All right, so let's write that out. And then the second part is going to be picking a divisor of 12. Okay, so we've already picked the 4, so we got that right there. So now we're just looking at these 3 right there. Okay, so those 3 are all going to be the divisors of 4. Okay, so that's going to be a 3 out of 3 chance. All right, and I have it all down right here as well. All right, so this is going to end up being 1/4 or 0.25. Because 1/4 times 3/3 would be 3/12, and reduce that down to 1/4. Okay. All right, so let's look at the next problem. All right, looking at this next one right here. So you have a piece of dice or die. What's probably rolling a number greater than 3 and then rolling a divisor of 40. All right, pause it, try it on your own first, see if you can get it using the same way that we did for the last one, and then you can start back up. All right, so hopefully you got through this one. Is going to be, first thing we're looking for is greater than 3, right? So let me underline that, greater than 3. So that would include 4, 5, 6. Okay, out of 6 different probabilities. So this is going to be a 3 out of 6, or that could just be 1/2. And then we're looking for rolling a divisor of 40. Okay, so 40 can be divided evenly by 1, 2, 3 doesn't work, 4, and 5. So there's 4 different possibilities there. So this would be a 4 out of 6, which is going to be, we're going to bring that down to 2/3, reduce that down, and then we're going to multiply those together. Okay, so you have 1/2 times 2/3. So let me just do that. And let me just write this a little bit nicer, actually. All right, so it looks a little nicer there. All right, so we have 1/2 times 2/3. So if we multiply it across, it'd be 2 on the top, 6 on the bottom. But hey, I'm working with fractions, I can cross cancel. So these are both divisible by 2. So I divide both of those by 2, which is going to give me 1. And then I'm going to end up left with 1/3 right there, or 0.333 if you want to put it in decimal. Okay, because they're asking for to write your answer in decimal around to the nearest thousandths. So 1/3 is going to be the equivalent of 0.333. Yeah. All right, so going to the next section, counting principle. Okay, first example here, one is selecting animals from new petting zoo. There are 10 ponies. I always like to underline what we're looking at, 10 ponies, 7 rabbits, and choose from those 2. Okay, and then we have how many different ways can one create a petting zoo with one of each animal. Okay, so counting principle, all you're really going to do is just going to be multiply all the different things you're looking for. So this one is going to be, there's 10 different combinations of ponies, there's 7 combinations of rabbits, and then here, that's it actually. So let me erase that. So this one is going to end up being 70. Okay. All right, looking at this next one, I'm going to ask you to pause it, try on your own, and see what you can come up with and come back. Okay, Abby is selecting animals from a new petting zoo. There are 2 ponies. There are 8 rabbits to choose from. And then for the goats, Abby has 4 different options. So there's 4 different goats as well. So how many different ways can Abby create a petting zoo with one of each animal? Okay, so give it a shot. All right, so what you should have gotten is gonna be this right here. So 2 times 8 times 4. So I'm looking at 2 ponies, 8 rabbits, and 4 goats. Okay, I'm gonna multiply all those together. It's gonna be 64 on that. All right, let's try one more. Steven's family is going to get a new hamster. They're going to get a hamster, but first they need to buy the supplies. Pet store has 9 cages, 4 kinds of wood shavings, and then 7 kind of water bottles. Okay, how many different ways can Steven's family set up a home for their hamster? Okay, so try that one. All right, so you should have gotten 9 times 4 times 7, which is going to give you 252. So 252 different ways on that one. All right, going on to the next section. All right, X5 permutations. First problem we're looking at, a band manager is planning tour dates for a series of rocket concerts. She wants to bring the band to Lexington, Livingston, Blue Point, okay, all those different places. How many different orders can the tour dates be scheduled? All right, so let's look at this one, look at the example they gave us. To find out how many different orders are possible, use a factorial. So we're going to be working with factorials in this one. So that's a little explanation point you see next to number. So when you see that, so there are 5 cities. So my explanation point would have a 5 in front of it. So that's just going to be multiplying all numbers under 5. So 5 times 4 times 3 times 2 times 1. And then that's going to give you the total of different orders. Okay, so that'd be, let's say the first one I go to Lexington, then I'm left with 4, right? So there's 4 different possibilities after that. Okay, let's say I did Livingston after that. Okay, then there's going to be 3 different combinations from there. So I have 3 things to choose from. All right, you kind of think of it like if you're going to fastball game and there's seats that you're looking for. There's 5 different seats. One person sits down on a seat, and then there's 4 left after that, and so on. Okay, so at the end of this problem is going to be a tour date can be scheduled 120 different orders. All right, let's look at the next one. All right, students in the music history class are given presentations on 6 different periods. And how many orders can periods be presented? Okay, so, or if you go to class and you have a schedule of 6 different classes, how many different ways can you have that scheduled? So that's just going to be a factorial of 6. And that's going to give you 720. So how do I get that? One thing you can do, so you can use Desmos, desmos.com. Click on the graphing calculator. And I can enter in 6 and then explanation point. Oops, let me do this here. And then it should just give you the answer right there. So if you want to use this, Desmos.com is a good site right there. You can use that, it'll save you some time. Otherwise, you just have to multiply it all out. So I just do all these together. Oops, it's not what I wanted. So 6 multiplied by 5, by 4, by 3, by 2, by 1, etc. Okay. I can also do this in this program. Multiply that out. Okay, you get the gist. All right, let's go back. All right, take a look at this one right here, and then pause the video, see if you can get it yourself, then we'll answer it. Okay. All right, so she has 5 recipes to choose from. How many can she bake? She can bake 3 of them. So this one's to be a little bit different where you're looking at choices. So this one is going to be 5 times 4 times 3. So 5 would be your first choice. Then there's 4 left and there's 3 left. Okay. So that's going to give you a total of 60 on that. All right, let's do one more here. Todd has 9 playing cards in his hand. How many different orders can he pick 4 cards and place them one at a time on a table? Okay, so you're going to start with 9. And then there's going to be 8 cards left. Then you're going to multiply it by 7 because there's going to be 7 cards left. So you're going to pick up to 4 on this one. So this one is actually going to be 3,024 different orders on that. Why did I keep going? Well, because they only asked me to pick 4 right there. Okay. So once I'm done, once I have 9, 8, 7, 6, that's my 4th pick was the 6 possibilities. And I'm going to stop right there. So it's going to be 3,024. All right, last section on this video is going to be permutations and combinations notations. This one's going to be the most challenging of the 4. All right, so let's just take a look right at it. So you're going to look at example here is going to be to evaluate 4C3. All right, so what does that mean? So this is going to be a combination. So combinations order does not matter. Okay, so it's like if you're going to pick up a card and you're going to replace it, it doesn't matter this order. Permutation is going to be order does matter. So you have n objects and you take R of them in a particular order. So it's going to be NPR. It's going to be National Public Radio. No, just kidding. It's combinations NCR is the other one. Number of combinations is a number of permutations divided by the number of permutations R objects, R exclamation point. So let's take a look at this a little more. All right. So there's a total number of permutations for P3, multiply 3 descending numbers starting with 4. Okay, so I'm going 4, 3, 2, and then 1 would just be 1. So it'll be 24 on this one. All right, number of permutations is going to be 3, and then you're going to go down from 3. So 3 times 2 times 1 is going to be 6. Okay, so you have 24 and you have 6. You're going to divide those 2 together, and that should give you 4. It's going to be your answer on that one. All right, so another way to look at it here is this formula right there. Okay, so how'd that work? So I plugged in, I had 4 on the top, 4 factorial, and then on the bottom I had my 3 right there. So I put the 3 on the outside, and I did 4 minus 3, which would just be 1. All right, and that's how I got to this right here. So 4 times 3 times 2 times 1, 3 times 2 times 1, and then times 1 on this. So it's going to be 24 over 6, which is going to give you 4. Ooh. All right, let's look at the next one. So permutation order does matter, right? Okay. So in this one, I'm going to use this formula right here. I'm just going to show you the steps right here. So you got NPR, an exclamation point on top, N minus R on the bottom. And then, so that'd be 6 factorial on the top, 4 factorial on the bottom. And then that's going to bring you down to this. So you can look at all those numbers, and these, nice thing here visually, you can just see them. They cross cancel. So you can almost skip this step right here. And then 6 times 5 would be 30. So your answer is going to be 30 on that one. All right, let's do one more. So 5C2. Pause, try it out. All right, so let's look at the steps. So order does not matter. So MCR, in exclamation point or factorial on the top, you got the R, factorial, and then parentheses n minus R. All right, so what's that going to look like? So you have 5 factorial, and then you're going to end up with 2 factorial times 3 factorial. All right, so you can get to this right here. You can do cross canceling if you like. And then you're going to try to solve from there. So if I cross canceled, I like to do that. The steps they're showing you here is to multiply it all out. But what's going to save you some time, if you want to just do this more in your head, is it's going to be cross the 3's out, cross the 2's out. 1 is always 1. And then it's basically going to be 20 divided by 2. All right, so that's going to give you down in 10.